Today's date, it's the 7th to 7/19. Okay, so today we want to talk about polynomials. Okay, which means many terms. Okay, polynomials, which means many terms. Okay, but we need a better definition. Yeah, Nick, you guys didn't get one?
Okay. Yeah, we can
Do you need three of them?
Yes.
Okay. Okay, so many terms. So the thing about polynomials, this is the most important thing, okay? They must have whole number exponents. Now, whole numbers are 0, 1, 2, 3, ... Those are the whole numbers, okay? So to be a polynomial, it has to have whole number exponents, okay? Otherwise, it's not a polynomial. It would be just a totally different type of thing, okay? So, a couple of examples on the side. So, if I had y equals x squared plus 3x, that's a polynomial. It's a polynomial because there's two terms, okay? But the exponents are whole numbers, right? That's a polynomial. In fact, we'd call this a binomial because it's got two terms, okay? That's a binomial, okay? If I had y equals 3x to the fourth minus 6x cubed plus 5x, that's a polynomial because the exponents are whole numbers, okay? This would be called a trinomial because it's got three terms. This would be called a trinomial. Okay. If I had y equals 4x to the fifth, that's a polynomial because it has whole number exponents, right? And this would be called a monomial. Even y equals 5, polynomial 5 is still a polynomial because you have an invisible x to the 0. Okay, so that's still a polynomial, and that would be called a monomial or a constant term. We're going to get it more. Something that would not, okay, not would be something like this: y equals a square root of x, or y equals absolute value of x. Those are not polynomials. Their exponents are different. You might say that it's next to the 1, but because of the absolute value, it's not. Now, polynomials like to roll. They're curvy, okay? The bigger the term, like x squared is a parabola. You've seen that, right? X cubed looks like this, okay? X to the fourth rolls a little bit more, right? X to the fifth has even more bumps, okay? The larger the degree, the more curve it can have, okay? So, back to the degree. So the degree of the polynomial is the biggest exponent. Right? The degree is the biggest exponent. So, for example, I've got a few examples up here. The degree of the first example is 2. It's just 2. The degree of this polynomial is 4. 4. It's just the biggest exponent makes the degree. The degree of this exponent is 5. That's it. It's easy, isn't it? The degree of this polynomial is 0. Okay? It's that easy. Now, sometimes they're not in order. What we mean by order is you've got to have the biggest exponent first, and then so forth, and then so on and so on. So, as an example, if I wrote this, if I said y, I want to do it up here. Y equals 5 plus 2x squared minus 3x plus 4x cubed. Okay, this example right here. Okay, it's a polynomial. It is a polynomial. Degree, what's the degree? 3. It is degree 3, right? But it's not in standard form. It's as easy as this. Yeah. Well, you didn't get mine because you just got here. Absolutely. There you go, Abby. So it is a polynomial because all of the exponents are whole numbers, right? 2, 1, 3, and then 0, okay? But it's not in order. It's this easy. We're going to rewrite it. So which is the biggest exponent? So we're going to rewrite. Y equals, we're going to put this one first, 4x cubed. Then we're going to put the 2x squared next, because it's got the next biggest exponent. Then we're going to put the 3x next, because it has next to the 1, even though the 1's invisible, right? Minus 3x, and then plus 5. So that's what we call putting it into standard form. To rewrite it in standard form, Archer, question.
What is it if it doesn't have any whole exponents? What's it called then?
Great question. So we're going to learn those. It's going to be either, for instance, sometimes it's going to be called a rational function because of square roots. It could be called a radical. I mean, they have all these different names, which we're going to learn. We know this one. This was an absolute value, right? Okay, great question, okay? So, not too hard, right? Monomial, one term, like this example. Binomial, two terms, like this one, okay? Trinomial, like 1, 2, 3 terms, right? That's a trinomial. Now, if it's more than 3, 4, 5, 6, we don't keep calling it. We don't. We're not going to do this. Quadnomial, pentanomial, hexanomial, septinomial, octanomial. No, we don't do that. Anything bigger than 3, we just call it a polynomial. Got it? If you have 4 terms, it's a polynomial. It's got many terms. 5 terms, call it a polynomial because it's got many terms. 6 terms, call it a polynomial because it has many terms. So, names more than 3 terms. The name will be just plain old polynomial. Okay? Does that make sense? We're not going to call it a quadnomial. They're silly. A pentanomial, hexanomial, septinomial, octanomial, nonomial, decanomial, dodecanomial. No. Just call it a polynomial. Got it? Okay. All right. So, example 1. Rewrite in standard form. You can do that. Rewrite this in standard form. Okay? Take 15 seconds to rewrite p of x, and we go p because it's a polynomial. P of x equals, okay? Go ahead and rewrite this in standard form. Okay, you can do this. Take 15 seconds, and you can do this in 15 seconds. Okay? 7x cubed, biggest, right? The exponent, not the number, plus 5x squared. Going to get there. Good question. Plus 4x minus 2. Okay, everybody agree?
Yep.
Biggest exponent all the way down. Just because the 7's a big number does not matter. The 7 does not matter. It's an exponent, right? Good. Perfect, Caden. What's the degree? What's the degree of this thing?
3.
Degree is 3. So degree 3. And what's the name? It's a polynomial. No such thing as a quadrinomial. Sounds stupid anyway, doesn't it? Quadrinomial. How about just plain old polynomial? Okay, got it? Now the leading coefficient, what number, after you rewrite it, is leading the charge? It's a 7. The 7 is the leading coefficient. It's that easy, okay? But you have to rewrite it first, but the leading coefficient is the number in the lead. Okay? It's not hard, is it? No, it's not hard. Okay, turn the page. Okay, all right. Now, if we're going to combine, add, or subtract polynomials, we add like terms. Okay? So, 3x cubed, x cubes with x cubes, right? X cubes go with x cubes. And now here's the thing. The answer is not x to the 6. I just say, okay, how many x cubes do you have? Got it? I've got 3 minus 4. How many x cubes? You got negative 1 or minus 1 x cubed. We've done this before, haven't we? Yeah, we did this in algebra. 2x squared with another 2x squared. How many x squareds do you have? 4. So positive 4x squared, okay? Negative 5x, positive 3x, okay? So negative 5x plus 3x makes a negative 2x. All right, good. Thumbs up? Not too bad.
I got a question.
Yeah.
What order did you do those in?
Yeah, great. Good question. So I like the same thing. What's the biggest? If I cubed, squared, x, what's the biggest ones of these? Cubed, squared, x. Which is the biggest one? Artem? The cubed, right? Because 3 is bigger. So let's do the cubes together. This cube with this cube.
So you're doing it by the size of the exponents.
Yes. Well said. Well said. And then x squares with x squareds, right? And then x's with x's, okay?
So you go the one on the left first, you go by the symbol. So it's 2x squared minus that, or do you add it?
I'm just going to add, well, I'm adding I subtracted these two. See where my fingers are? Okay, I'm subtracting these two because it really is 4 subtract because I see the subtract.
Symbol in front of
Right, symbol in front of, right. And then this is a positive 2 with another positive 2, right? Makes 4. This is a negative 5 with a positive 3. Negative 5 with a positive 3. Makes negative 2. Now, subtracting, okay? So a lot of ways to subtract, but you got to be careful, okay? First of all, I'm going to do it wrong. And I want you to see what I'm going to do wrong, okay? I'm going to do it wrong, so don't write this down. Got my eraser. I'm going to do it wrong, okay? 4x cubed minus 7x cubed. That's a negative 3x cubed, okay? Negative 3 minus 5 is a negative 8x. And 7 minus 8 makes a negative 1. And then I've got this 2x here, plus 2x squared, okay? That is totally wrong. Okay, I'll do it again. What's wrong with that? What did I do wrong? Sure seems like I did it right, didn't I? I mean, let's do it again. 3x, that minus that makes a negative 3, okay? This minus this makes a negative 8, right?
No.
Ah, see, okay, good. Let me keep doing it wrong, Derek, and I'm going to come back to what you said, okay? 7 minus 8 makes a negative 1, right? What's wrong with that?
You're subtracting the negatives.
Yes, I'm going to say that in a second, okay? And then I've got at the end my 2x squared because there's nothing else but the 2x squared. Now that is wrong. Now why is it wrong? Derek, will you say it again for me, please?
When you subtract negatives,
Right. See, I'm going to subtract. The easiest one to see is this one. Okay, you got to be careful on these. I'm going to take let's take the 7. 7 minus a negative 8. 7 minus a negative 8. This is 7 minus a negative 8. So that's confusing, isn't it? So here's what I want you to do, okay? So you never mess it up, okay? You don't have to. If you're a super genius, you can do it in your head, great. But here's the trick, okay? We're going to distribute the subtraction through first. Okay? So I'm going to distribute the subtraction through first. What does that mean? This negative right here, this subtraction, I'm going to bring through. And then I'm going to add. This keeps me from making a mistake. Now some kids can do it in their head. Some kids don't need to do this step, but it really is handy. So watch. Here's what I'm going to do. Now, I'm going to get a negative 7x cubed. I'm going to get a negative 2x squared. You see what I'm going to get my negative? My negative goes to my 2x squared, makes it negative. Now, this negative goes to this negative. A negative to a negative makes a positive 5x. This negative goes to this negative, which makes it a positive 8. Okay, now let's rewrite what I have. I've got a 4x cubed minus 3x plus 7. Okay, so when you subtract a big group like this, if it's in parentheses, bring the negative through first so you don't mess up on the double negatives. You don't want to mess up on the double negatives. Now it's easy, okay? Archer and we'll do it together. Okay, these together, right? Okay, you agree? These two, which will give me a negative 3x squared. This will be the answer. Negative 3x cubed. Negative 3x and a positive 5x. Positive 2x. Good. I've got a negative 2x squared, right? Is there any other x squareds to do?
No.
So it's just a minus 2x squared. And then a positive 15. Now, there's one more thing I should do. what should I do? One more thing I should do.
Put it in standard.
Yep. Let's get this one, the x squared, before the x. Nice job. So I'm going to go minus 3x cubed minus a 2x squared plus 2x plus 15. Very good. Yes. So I probably would never mark this wrong on a test, but it should be in standard form, okay? Last but not least, okay, example 4, it's the same thing. Except it's got x's and y's and x's, okay? And it's a little tricky because x squared y, are you watching? Everybody watch, okay? X squared y is different than xy squared. It is. X squared y is different than xy squared. They almost look the same, but x squared y is the same thing as this x squared y, right? X squared y here to there, and then xy squared is the same thing as this. No, that's the only one up there, isn't it? Yeah. Okay, so let's first bring the negative through, okay? First thing I'm going to do is I'm going to bring this subtract through, okay? Do that first, okay? So let me rewrite this as a negative 3xy plus 4 plus 4xy squared minus 5x squared y, okay? Write that first. Bring the negative through. Now I'm going to bring everything else down. 3x squared y plus a 5xy squared plus a 1xy, okay? Now, what goes together? Let's see. Let's see if I can find like terms, okay? That's x squared y. That's an x squared y, right? Those are the only x squared y's, you guys agree?
Yep.
So 3 minus 5 makes 2 of those. 2 of those. What are those? Well, those are the x squared y's. So I'm going to have a negative 2 x squared y. Okay, now I've got a 5xy squared. Okay, that's, let's see, different color. Okay, let's do that one in purple. Okay, got one there, and I've got another one there. Right, those two are the same. You guys agree? So let's put those together. Okay, so let's see. That gives me 5 plus 4 makes 9 of what? I'm adding these. I'm adding 9xy squared. And then finally, the last two I can put together are the xy's, right? Those two right there, which makes a negative 2xy. Okay? Let's look at our journal. Let's have another opportunity to look at this, okay? So grab your journals.